Good morning, friends. We will talk about the morphology of lamellibranchs in this lecture. And as you all know that the lamellibranchs belong to the phylum Mollusca. So, it is very useful for us to know first that what is the primary feature of the phylum Mollusca. All the mollusks, they have calcareous shells, and as you can see from each of the specimens that all of them nearly they are all calcareous shells, except for the forms which are fossils and they have been converted into molds. So, this cannot be said for those forms, but by and large all the mollusks have the calcareous shell. As far as the symmetry is concerned, they have the bilateral symmetry. So, the presence of the calcareous shells and the bilateral symmetry, these are the two features that class a particular form as the mollusk. Now, in the mollusca, especially they are all lamellibranchia, they are also called as bivalvia or Pelecypoda. So, there are some peculiar features of the lamellibranchia also, like the presence of the two piece shells. Each lamellibranch contains two pieces of the shells. These two pieces, they are from different animals. So, if this is one piece, there is a similar piece also. As far as their orientation, biological orientation is concerned, they have the mouth towards anterior side. Let me tell you with reference of a particular shell that this particular portion is the dorsal part, opposite to this is ventral part. Then as far as the anterior and posterior is concerned, if you draw a line from the umbo to the ventral margin, this is ventral margin, this is dorsal margin, and this is umbo. So, from the umbo, if you draw a line to the ventral margin, this divides the shell into two parts. As you can see, both parts are unequal. So, the smaller portion, that means this one, you can see it again, that this smaller portion is the anterior side. So, the head would be towards this. By this method, we can assess the biological orientation of the organism when only the shell is left before the observer. So, one primary feature of the lamellibranchia is that it has two piece wall, the mouth is towards anterior side. Now, before we start the formal description, I would request you to have a pen and paper and keep noting down the points that we will discuss consecutively. The first thing a person should note down while studying a lamellibranch is its shell form, that means the form of shell. The form of shell consists of three distinct parts to be studied. The first is the size. Size means you can say that this happens to be small size shell, this is medium, this is little larger. So, and this will also be within the large category. So, you can manually and visually divide the size into three categories: the small, medium and large. Then comes the shape. Shape is basically a geometric term. Like for example, you can say that this is elongated or elliptical shape. Then if you observe this shell, this shape of this shell would be rectangular. Additionally, this shape, the shape of this shell is also rectangular. However, if you see this particular shape, this is trigonal, this is curved, this is also curved. If you try to see the shape of this shell, this is little broken towards the side. So, you can see, and if you reproduce the broken part, this will be semicircular, as you can see. This is also elongated. So, we have completed two parts in its description. The first is the size and then the shape. Then comes the symmetry. The shape, size and symmetry, all these three features come under the shell form. That means, we are discussing form of the shell, in which we have discussed size and shape. Now, we will be discussing the symmetry. Symmetry means the shell would be either equilateral or inequilateral. Like if you see this, drawing a straight line from the umbo, this divides the shell into roughly two equal parts. So, this is equilateral. Now, drawing a particular line from the umbo is probably here. So, if you can draw a straight line from the umbo, this does not divide the shell into two equal parts. So, this is also inequilateral. Here also, this is the umbo. If I draw a straight line from the umbo down to the ventral margin, this also becomes inequilateral. So, as you have seen that the particular shell is either equilateral or it is inequilateral. Hence, in the form of the shells we have discussed size and shape, and in the symmetry we have discussed the whether the shell is equilateral or inequilateral. Shells can be equivalve and inequivalve also. What is equivalve and inequivalve? This is primarily attributed to the fact that the two pieces of the shells must be identically equal. That means, the other shell of this particular form will be exactly the mirror image of this one. Sometimes the two shells, they are unequal. Like for example, if this, you can consider this form, this is Griffia, and in this form this shell is particularly larger. The other shell will be a kind of a small shell, and the two would be significantly dissimilar, and such shells are called as the inequivalve. So, inequivalve shells have two dissimilar shells. So, this is the first part that we have discussed about the form of the shells. The second part which is to be seen is the umbo. Umbo is the topmost portion of the cell. Like here, if you see, this is umbo for arca, this is the umbo for venus, this happens to be the umbo for spondylus. For Inoceremus, we have pointed umbo. For the Mytilus, we also have an umbo here. Then in Austria, we have umbo here. So, as we have seen, the highest portion of a shell is basically the umbo. Let me remind you again about the biological orientation of a particular shell. In a particular shell, how to find the dorsal, ventral, anterior and posterior. The part where the highest portion, that is the umbo, lies, it is the dorsal part. Opposite to the dorsal is naturally ventral, and then to find the anterior and posterior, you have to draw a line, straight line from the umbo to the ventral margin. As you can see, this line divides the shell into two unequal portions. The smaller portion is the anterior and the bigger portion is posterior. Now, as you are aware how to identify the dorsal, ventral, anterior and posterior. Now, let me tell you how to study the umbo. Umbos can be straight and central. As you can see here, umbo is straight. It is neither curved toward the anterior side nor it is curved toward the posterior side. So, this is the straight umbo. So, spondylus is an example of the straight umbo. Now, umbos can be curved towards anterior side, they can be curved towards posterior side. Now, here if you see, this particular umbo is inclined in this direction, and this direction is the anterior side, because it is the smaller portion with reference to a line drawn from the umbo to the ventral margin. So, this happens to be the anteriorly curved umbo. So, in umbo you have to describe it either central or anteriorly curved or posteriorly curved. After the umbo comes the hinge line. Hinge line, and what is hinge line? Actually, hinge line is the line along which the two pieces join. As you can see, this is the line which is the hinge line for this particular shell arca. Hinge line. This is the hinge line for Unio. This is the hinge line for the Venus. As you can see, the hinge line, the main feature which you can observe in the hinge line is whether the hinge is straight or not. That means, if you see the hinge line in arca, that is completely straight. If you see the hinge line in Unio, this is also a straight line. So, the hinge is straight, but if you see the hinge line in the Venus, this is curved. So, you have hinges which are straight and you have hinges which are curved. Here also you have the hinge line which is curved. If you see Austria also, you have the curved hinge. So, you can have the hinges either straight or curved. One more particular feature one can observe in the hinge is the dentition. Now, if you closely observe the hinge, on the hinge you can see very small pits, and these pits, they are called as dentition. Dentition is also a very significant feature in the lamellibranchs or the bivalves to be identified, and different lamellibranchs or different pelecypods or different bivalves can have different form of and different kinds of dentition. Like for example, starting from the arca, as you can see on the straight hinge of the arca, there are numerous, you cannot count, there are too many. So, too many pits are present. So, these pits are numerous and they are present on the straight hinge, and such kind of a dentition is called as taxodont dentition. I have requested you in the beginning of this lecture to always hold a paper and a pen and keep noting down these things in a consecutive manner. So, I hope that you are noting down these things somewhere. So, the first kind of dentition we have discussed is the taxodont dentition, and this is present on a straight hinge in arca. Then comes the schizodont dentition. You can see below the umbo you have the bifurcating teeth present, grooved and bifurcating teeth which is present. This is called as the schizodont dentition, and this particular dentition is a specific feature of trigonia. So, two kinds of dentitions we have discussed, taxodont and schizodont. Then comes the heterodont dentition. Heterodont dentition, to have an idea about the heterodont dentition, let us see this. We have the two, heterodont means two different kinds, hetero means different. So, here we have two different kinds of the dentition. One is the cardinal teeth, dissimilar teeth, and another is roughly parallel to the hinge, and that is called as the lateral teeth. So, the presence of cardinal teeth means the unequal teeth, and the lateral teeth is almost parallel to the hinge. So, these two different kinds of the teeth present on the curved hinge is basically called as the heterodont dentition. Then comes the desmodont dentition. Desmodont dentition is usually found, actually it is not a dentition, it is a kind of fold onto the hinge line that gives a pseudo impression of the dentition. So, this is called as the desmodont dentition. Then comes the disodont. Disodont means weak teeth. Weak teeth, as you can see, the teeth is not that much well developed beneath the umbo. So, this kind of a dentition is a peculiar feature of the Mytilus. Then at the last comes the isodont dentition. Isodont means you have the sockets on the one valve and the protuberance of the teeth on the other valve. So, the two fits very well. So, on the either side of the ligament pit, this is called as ligament pit. So, on either side of the ligament pit, we have the dentition present, and they are almost similar with pits on one valve and the teeth on the other. So, the two fits very well. This kind of a dentition is called as the isodont dentition. So, we have discussed the form of shell, shape, size, symmetry. Then we have discussed umbo. Umbos can be straight, they can be anteriorly curved, they can be posteriorly curved. Umbos even can be spiral, as you can see in the exogyra. Then we have discussed the hinge line, they can be straight, they can be curved. Sometimes they are very thick and they form the hinge zone as in spondylus, and on the hinge there are prominent dentitions, the type of which we have already discussed. After this, the next feature to be observed in lamellibranchs by any paleontologist or a geologist or an observer is the muscle scar. Muscle scar, it is the scar, this is the hard part actually. So, muscle scar is the scar which is left after the animal dies. So, this is the point where the animal soft part was attached to this shell, so that if the shell gets tilted, the animal does not fall. So, you have the scars after the death of the animal, this scar is left, and this scar also is very significant in identifying the shells. Like here, if you see, there is only one subcentral large dark colored scar. So, this particular case where you have only one muscle scar is present, it is called as monomyrian, M-O-N-O-M-Y-A-R-I-N. So, monomyrian is the case when the shell is having only one scar. Sometimes these shells have two scars present. As you can see in this shell, there are two muscle scars. So, they are called as dimyrian. So, on the basis of the muscle scars, you can divide the shell into monomyrian and dimyrian. Like these spondylus, you have a large subcentral muscle scar present. So, this is monomyrian. Then in the ostrea, you have single muscle scar present, that is also monomyrian. Then we have in the arca two muscle scar present, it is dimyrian. So, we have monomyrian and dimyrian. When you have dimyrian condition, that means you have two muscle scars. So, it is very natural that either the two muscle scars will be of the same size or they will be of different sizes. So, if they have same sizes, it is called as isomyrian. As you can see in arca, the two muscle scars, they have same sizes. So, first it is dimyrian, and in dimyrian it is isomyrian. In many forms, the two muscle scars, they are not equal, they may be dissimilar. As you can see here, there is slight difference between the two muscle scars. So, it is called as anisomyrian. So, we have dimyrian condition in which we have isomyrian when we have two same size of muscle scars, and anisomyrian when we have two dissimilar muscle scars. And whenever you have the dimyrian condition, that means two muscle scars, whether they are similar or dissimilar, there is a line that joins the two. As you can see in this particular shell, these are the two scars, and this is a line, very faint line, it is not that well very well visible. Now, we will be discussing about the ventral margin, that is the next part to be studied. Before that, let me tell you a method to find out whether the valve you are looking is a left valve or a right valve. Because the umbo lies on the dorsal margin, this is what I have repeatedly said in the entire discussion, that the umbo lies on the dorsal margin. So, if you join the two valves together, one will be the right valve, the other will be left valve. But how a person will know whether the valve he or she is looking at is a left valve or a right valve? To do that, there is a method. Let us find out. Say for example, we observe this particular valve. In this valve, this is the umbo, and I draw a straight line from the umbo to the ventral margin. This is the line. This line divides the shell into two unequal parts. One is a smaller, towards this side is a smaller, towards this side is bigger. So, the smaller one is the anterior side and the bigger one is the posterior side. So, keep umbo up, anterior away from you and posterior towards you. The hand in which it fits represents the valve. That means, if I keep the umbo towards top, the anterior away from me, the smaller part away from me, the bigger part or the posterior towards me, it fits in my left hand. So, this is the left valve. Now, let us check out the other one. This is the other shell, this is umbo. I draw a straight line from umbo, and this divides the shell into two unequal parts. This is the smaller portion, this is the bigger portion. Smaller one is anterior, the bigger one is posterior. Now, I keep the umbo up, anterior away from me, posterior towards me. This fits in my right hand side. So, this is the right valve. So, we have observed one left valve and one right valve, and we have also learned the method how an observer can find out whether the valve he or she is looking is a left valve or a right valve. Then we will come to the ventral margin. As we have seen, opposite to the dorsal margin is where the umbo lies, the opposite to which is the ventral margin. The ventral margin can be entire and smooth, as you can see here. The shell is thin, the ventral margin is smooth. Here also you can see ventral margin is smooth. But in ARCA, the ventral margin is crenulated. As you see, this is not smooth, you can see a zigzag line. So, the ventral margin is to be designated as entire, smooth, or it is crenulated. So, in ARCA it is crenulated. This is a form which is called as unio. Here ventral margin is smooth. This is venous. Here also it is slightly crenulated. So, this is not smooth, rough, you can use any term. This is Austria. Here also the ventral margin is smooth. In forms which are fossils, like this is Inoceremus, and you cannot find out whether the ventral margin is smooth or rough. You can say that it is not distinct or it is indistinct. After the ventral margin, the next part which is to be seen is the external surface. How is the external surface of the shell? External surfaces, they have also very different kind of ornamentation, and this ornamentation also can be used as some sort of an approximate identification of the form. Like for example, if you see Unio, the ventral margin contains concentric lines which are distinct. On this shell, which is Arca, the external margin contains radial ribs. These are not lines, and instead of calling these as lines, it is called as ribs. So, it is because of the prominent ornamentation on the external surface that the ventral margin looks granulated. The external ornamentation sometimes becomes so strong that it has impressions on the internal surface also. So, this is the radial ribs. Then sometimes you can have the knobs arranged in line. You can see the knobs arranged in line. So, this is one also a sort of ornamentation. In Inoceremus, you have the concentric lines, rather these are not lines, rather these are concentric ribs, because these are little thicker. These can be said as lines, concentric lines. So, you have to understand the difference between the concentric lines and concentric ribs. So, these are concentric ribs. So, in order to identify a particular form like this one, you have pointed umbo, straight hinge, the semicircular shell and concentric ribs. So, these are the features which are enough for anyone to regard this particular form as Inoceremus. Now, as you have seen, there are a lot of external ornamentation. So, we are continuing with the external ornamentation. Sometimes you have the radial ribs present, and these ribs are little thicker. Sometimes these are called as costae. So, you have radial costae present. In Austria, the external ornamentation is defined by the radial costae. Sometimes the external surface is smooth, as in Griffia. As you can see here, the external surface is smooth. In still other forms, the external surface can be pitted. As you can see in Spondylus, the external surface is pitted. In some forms, we have cancellating ornamentation. What is cancellating ornamentation? Sometimes we have concentric lines, and then this is cancelled by the radial ribs. So, this is called as cancellating ornamentation. This is a peculiar feature of the Venus. So, as you have seen, the external ornamentations, they can have smooth, they can have the radial ribs, they can have the concentric lines, they can have the concentric ribs, they can have the radial costae, they can have cancellating ornamentation like in Venus, they can have tubercles or knobs as in Trigonia. So, as you have seen that there are so many forms. Here the external surface is marked by these spine like features, which are nothing but you have very strongly developed folds on the external surface, like in Lofa. So, you have, and Lofa is also called as electronia. Some other literature refer Lofa as electronia. So, we have many forms of the external ornamentation present in the bivalve or lamellibranchia. Then comes special features. We have discussed many of the features which are diagnostic. Then there are some special features peculiar to some form. Special features like, for example, if you want to identify spondylus, how will you? First, it is equivalve, equilateral, it is having a triangular pit, isodont dentition, thick hinge area, large subcentral muscle scar, that means it is monomyrian, the external surface is pitted. Sometimes you can see punctures or bores on the shell, as you can see here, as you can see here, here. These bores not all of them, but some of them can be because of some organism has attacked onto it and has sucked the soft parts. Sometimes they inject some poison or the toxin through this puncture, and that kills the animal. So, not all the holes present or the scar marks present on the surface, they are due to some attacking by some predators. If you talk about Austria, the special feature is again the large subcentral muscle scar, and then you have the triangular ligament pit present. The shell is thicker. The presence of very strongly developed folds, it is a special feature of the Electronia or Lofa. The straight hinge, anteriorly curved umbo, strong radial ribs, and then spines present on those ribs is something that characterizes Arca. Strongly developed concentric ribs with pointed umbo and straight hinge characterizes the Inoceremus. Spiral umbo characterizes Exogyra. So, this is the special feature of the Exogyra, that is the presence of spiral umbo. Sometimes we have the cancellating ornamentation, heterodont dentition, presence of the pallial sinus or the sino-palliate condition, that is a characteristic feature of the genus Venus. The presence of thin elongated shell with very weakly developed dentition is something that characterizes Mytilus. Sometimes you can compare the features, like for example, if you see this is a shell which is medium, but with a long hinge line. This is a shell having a short hinge line, but is a big shell. So, shells are sometimes bigger with short hinge line, sometimes the shells are smaller with a big hinge line. You can see the term functional morphology comes into being in these cases. Like all the parts which we have discussed about the lamellibranch is used in some of its life form functions. So, every particular biological feature is having a task, is having a specific ecological task to be completed. So, then comes the age, which is the final point to be studied in any lamellibranch form. Some of the lamellibranchs are index fossils. Index fossils are those fossils which has a short geological range and the long horizontal range. That means they occur on earth for a short period of time and they occur everywhere. So, such fossils are called as index fossils. Inoceremus is one such example of the upper Cretaceous index fossils. So, age of Inoceremus is upper Cretaceous. For the Spondylus, this is not an index fossil. It started from Jurassic and it is even found now. So, the age range is Jurassic to the recent. Trigonia is Triassic to recent. Exogyra, it started in Jurassic and it became extinct in Cretaceous. Then comes the Lofa. Lofa is Triassic to recent. Then Arca is also Triassic to recent. Then Austria, this is Triassic to recent. So, as you have seen, as far as the age is concerned, some of the forms are index fossils while the others are not. Those that are long ranging form that started in the very beginning and they still are found now. So, they are good paleoecological indicators, and those that occur on earth for a short period of time, they are good index fossil. So, they give the age marker determination to the particular strata. I hope you have enjoyed or you have understood the description of the lamellibranch, the practical approach to study the particular shell. Whenever you find a particular lamellibranch shell, you think that it is lamellibranch, do not try to identify it. There is no point in identification. You can identify the features, and when you combine these features, that automatically will point towards a particular phylum, a particular class or a particular order or a particular genera. Till then, thank you very much.